Ahoy there, mathematics learners! It is another adventure to seek the hidden gems of mathematics. Come with us to sail under the deep, wonderful sea to discover the beauty of solving. The first presentation entitles The Treasure of Mathematics, Linear Inequalities, with the theme Unlocking Mathematical Riches Through Exploring Systems of Linear Inequalities. And for the second topic, it entitles Optimizing Efficiency, Unleashing the Power of Linear Programming, with the theme Unlocking Potential, Harnessing the Power of Linear Programming for Optimal Solutions. Before knowing what system of linear inequality is, let us know first what is linear inequality itself. When we say linear inequalities, it is a mathematical statement that contains linear expressions and inequality symbols and depicts a connection between two quantities showing that one is greater than, less than, or equal to the other. Like this, for example. When we say systems of linear inequalities, it means a set of two or more linear inequalities that are considered together. It can be written in two forms, standard form and slope-intercept form. Like this, for example.
Ahoy, Sailor Gretel! One of our semantics friends had a little confusion. So what is the difference between linear equation to linear inequality? What a good question! The main difference between a linear equation and a linear inequality lies in the type of relationship they represent. A linear equation is an equality statement that equates two linear expressions. For example, 2x plus 3y is equals to 5 is a linear equation. On the other hand, a linear inequality is an inequality statement that compares two linear expressions. For example, 2x plus 3y5 is a linear inequality. In summary, a linear equation represents an inequality relationship between two linear expressions, while a linear inequality represents an inequality relationship between two linear expressions.
Ahoy, mathematics sailor! Let's open the shell of the solution with graph. Now, in linear inequality, an ordered pair of x and y is a result of an inequality in two variables. A true statement results when the variable in the inequality are replaced by the coordinates of the ordered pair. We ought to find the right solution of the given problem by computing ordered pair that would result to a true or would satisfy our inequality. Let us take this for an example. X plus 2y greater than 11 and negative 2x plus y less than negative 7. The ordered pair we will be using first is 6 and 3. 6 plus 2 multiplied to 3 greater than 11, it would now 6 plus 6 greater than 11, which would give us 12. Since 12 is greater than 11, this solution is true. To make it more valid, let's try the ordered pair on the other one. We have negative 2, x plus y less than negative 7. Replace the variables to 6 and 3. Negative 2x times 6 plus 3 less than negative 7 will result to negative 12. Sum up to 3 less than negative 7 and it will give us negative 9 less than negative 7, which is indeed true. Therefore, the ordered pairs satisfy both the inequalities. For another ordered pair, let us have Sailor Roniel.
Ahoy, ahoy! Thanks, Sailor Disrael. Let us now use another ordered pair if it satisfies the inequalities as well as what was shown on the first example. Let us use 5 and 3, replace x to 5 and y to 3. 5 plus 2 multiplied to 3 greater than 11 will result to 5 plus 6 greater than 11, which will result to 11 greater than 11. This could be a true statement. However, it does not have an equal sign, so it is considered false. For negative 2x plus y less than or equal to negative 7 is still the same. Replace the x and y will have now negative 2 times 5 plus 3 less than or equal to negative 7, with a result of negative 10 plus 3 less than or equal to negative 7, and will have now negative 7 less than or equal to negative 7, which is true. However, both must satisfy the inequalities. In this problem, only one did, so it is not a solution of the system. Now let us see the graph of this problem with Sailor, Chanel, and QJ.
Let us understand our graph here. In our linear inequality with two variables, our graph is a half plane. As you can see, the line of the graph here is the solution of linear inequation, while the linear inequalities is the shaded region of the graph. It could be the bottom part of the graph or at the top, but it always be half. The shaded part of the region consists of the points whose coordinates satisfy the inequality. All the ordered parts that are included on the shaded region are the solutions of the system. Let us try to graph the example Sailors, Roniel, and Israel has given earlier. Let us follow the systematic process of graphing. First is to write the inequality as an equation and solve for its intercepts. We'll now have x plus 2y is greater than 11, to x plus 2y equals 11, and negative 2x plus y is greater than or equal than negative 7, to negative 2x plus y equals negative 7. To solve for x-intercept, let us make y as 0. X plus 2 multiplied by 0 equals 11, x plus 0 equals 11, x equals 11. Solve for y-intercepts again by making x as 0. 0 plus 2y equals 11, 2y equals 11, y equals 11 over 2 or 5.5. Let us use 6, 3 as our test point. 6 plus 2 multiplied by 3 is greater than 11. 6 plus 6 is greater than 11. 12 is greater than 11. Since 12 is greater than 11, the inequality x plus 2y is greater than 11 is satisfied by the test point and it is true. Let's see now on the graph. First, graph the x and y intercepts 11, 0, and 0, 5.5 to connect. Let us graph the equation x plus 2y equals 11. This will now serve as our boundary line. The test point of this will guide us to know if it is included in the shaded region. As you can see, the x and y, even our test point, is included on our shaded region. Every ordered pair that is part of the shaded region are solutions to the given system.
What about the second equality of the given problem? We have negative 2x plus y less than negative 7. Rewrite in equation and find its intercept. Same process as earlier. Replace x to 0 to get y intercept. And replace to 0 the y to get the s-intercept. It will be negative 2x plus 0 is equal to negative 7. Negative 2x is equal to negative 7. S is equal to 3.5. For y-intercept, negative 9 is indeed lesser than negative 7. Here is the visual representation of the plotting graph. Now you can see the s-intercept and y-intercept are belong to the shaded region. Even our test point is included on our shaded region. Now, what is linear programming? It is a mathematical optimization technique used to find the best possible solution for a given objective function, subject to a set of linear constraints. Note that optimum solution means the best possible outcome. Now, the general formula of linear programming problem is written as this.
Ay! Here's an example. A furniture company makes bookshelves and desks. Each shelf requires 2 hours for carpentry work and 1 hour for painting. Each desk requires 3 hours for carpentry and 4 hours for painting. The company has a maximum of 60 hours of carpentry work and 40 hours of painting available each week, and they make a profit of 15 per shelf and 40 per desk. How many shelves and how many desks should they make? Let us organize them using this table. We have our constraints here. 2x plus 3y is less than divided by 60 and 1x plus 4y is less than divided by 40.
We'll be finding the x and y intercepts. We'll be having the same process for the second one. The x-intercept is now 40, and the y-intercept is 10. After connecting the two lines, we will then shade the both. Now, we will have our feasible region.
The feasible region refers to the set of all possible solutions that satisfy a given set of constraints in an optimization problem.
Now, sailors, after that, we will then find the corner point of the region. There are 4 including the origin or the 0, 0. Over on the x-axis is the 30, 0, while on the y-axis is 0, 10.
For the last point, which is 24 and 4, we'll have 520 profits, and that's how the linear programming works. Linear programming plays a crucial role in the modern world due to its ability to optimize resources, utilization, and decision-making processes.
It is indeed fun to swim under the sea, to seek treasure, and love the riches of mathematics. Thank you for coming with us. See you on our next journey. Bye!